Hello everyone, and welcome to week 5 of Poll 361. This week we will be discussing causality and causal inference. In the part 1 series of this video lecture, we're going to discuss 3 distinct types of statistical relationships: causality, correlation, and spurious relationships. We'll also discuss 4 of the most popular methodological approaches and how each of these methodological approaches have various constraints or the extent to which we can claim relationships between variables are causal, correlated, and spurious. So in part 1, we'll discuss experimental studies, observational studies, field studies, and case studies. And in the part 2 series of this video lecture, we'll discuss other methodological approaches that are a little bit more advanced or require very nuanced research topics to use these type of methodologies. But in the part 2 lecture, we'll discuss natural experiments, intervention analyses, single case studies, cross-sectional analyses, and longitudinal analyses. So with that being said, let's go ahead and get started. So what is a causal claim? What is causality, and why do we care? Well, causal claims communicate how the variation of one phenomenon cause changes in another phenomenon. So this probably sounds really familiar to you by this point. It is the essence of what our hypotheses strive to explain. So an example that we've used quite frequently: as x increases, that's our independent variable, it will cause a decrease in y, for example. We are trying to prove, or at least demonstrate, that changes in x cause changes in y, trying to demonstrate that as our independent variable changes, it causes other changes in y. This is the nature of causality, and it's a key component of theories and hypotheses. So for example, say we were interested in examining the impact of watching negative campaign advertisements and the impact that had on the likelihood of a person voting in a given election. So very simply, we could throw together this crosstab. Say we asked a variety of people. First, we operationalize our dependent variable, which is the likelihood that they will vote. So that's here in column Y. Did you vote? And they could respond yes or no. And then we could also ask them questions that operationalize our key independent variable in question, whether they've been exposed to negative campaign advertisements. So they could respond, yes, I saw a negative ad in the last election, or they could respond, no, I did not see any negative ads in the last election. And so with a very crude analysis of this crosstab, we could investigate how exposure to a negative advertisement or no exposure to a negative advertisement, did that have any impact on the likelihood that the respondent or the individual that we surveyed actually voted in the previous election? So we can look here at this column, did you see a negative ad in the last election? We see, interestingly, that 100% of people who did see the negative advertisement also did not vote. And when we look at the second column, did not see a negative advertisement, we see that 100% of people who saw no negative advertisement, well, they did vote. So this might beg the question, well, did watching or not watching the negative advertisement, did that cause people to vote in a specific way? So just looking at this data on its face, we might jump to the conclusion that, yeah, maybe people who saw a negative advertisement, that resulted or caused them to not vote. And the job of a data scientist is to always be thinking about these other independent variables, these other explanatory factors that might also cause the dependent variable to occur. And you might remember this from the arrow diagram lesson of the intervening variables. And those are what we refer to as spurious relationships. So we might think that our key independent variable of interest is causing the dependent variable, but we also have to think about these spurious variables that might intervene, and they might actually cause the variation on both the independent and dependent variable. So what this graph is illustrating is that we assume, or we theorize, or even hypothesize, that exposure to negative campaign advertisements, that will cause lower turnout. But what other things might also cause low turnout? And one of the most frequently cited variables in this literature is your level of education. So people with very low education, they might also be very unlikely to vote. You know, we need a lot of information in order to feel confident about the vote that we cast. So if you don't have very much education, you might already be predisposed to turn out and vote. And the same could have an impact on your exposure to negative campaign advertisements. I mean, generally these are aired on channels that, you know, play the news or, you know, other very specific television programs. So, you know, your education might impact the amount of TV that you watch. And, you know, if you're even watching a channel where negative campaign advertisements are likely to be aired. So in this example, education is referred to as an intervening variable. It's a spurious relationship. So it might not necessarily be that watching a negative ad causes low turnout. Those things might appear to be related, in other words, correlated, but it actually might be education that's causing the dependent variable to occur. So let's break down these definitions in a little bit more detail. So first we have causality, or causal relationships. And these are the, you know, traditional hypotheses statements that you've been making all semester. So a causal relationship is one that tries to suggest that changes in that changes in X, our independent variable, that those directly cause changes in Y. So causality, very easy to remember. We're suggesting that changes in X cause changes in Y. Correlation is much different than causality. And really what correlation means is exactly what it sounds like. X might not cause Y, but X and Y are probably really closely related. They're probably just really correlated. So X and Y may increase and decrease together, but the cause is independent of the relationship. And we'll walk through some examples in just a moment, so don't worry. Just remember, causality means we're talking about X causing Y. Correlation just means X and Y are related. And spurious relationships are like the ones that we just discussed. X and Y may appear to be related, or even causal, but a third factor, which is often referred to as Z in our statistical equations, Z is actually influencing both factors and dismissing that suggestion of a causal relationship. Now, in order for a relationship to be causal, it generally has to meet three of these conditions, all three of these conditions, really. So let's walk through these for a moment. The first is covariation, which obviously is just like correlation. So what we're saying here is that the variables in the study, X and Y, our independent variable and our dependent variable, they must covary in order for us to presume that there is in fact causality underlying the relationship. So for instance, as X increases or decreases, the value of Y must also increase or decrease. So we first have to prove that there is some type of relationship between these two variables before we can even jump to the conclusion that they are causal. So we refer to this as covariation. We must identify at least some type of positive or negative relationship between X and Y. Second, which is pretty self-explanatory and common sense, time order matters. And this is more of a concern for your theory and the explanation you are giving for why these two variables should be causal. But generally, the research must demonstrate that the cause precedes the effect. So if you're suggesting that X is causing Y to happen, but X actually happens after Y, well, that doesn't really make much sense. You can't say that something caused another thing to happen when the nature of the cause happened well after the effect. So time order, a very simple, very easy one to understand. The cause must precede the effect. And then third, we have to eliminate those confounding factors, those spurious relationships, those intervening variables that we have already talked about. So again, spurious variables, which may impact X and Y at the same time, we have to rule those out. Otherwise, we're not truly demonstrating that X and Y are in fact in a causal relationship. So let's just walk through a couple examples to make sure that we understand the difference between causality and correlation, and just how simple exercises of logic and thinking through a problem logically can help us understand whether or not a relationship is causal or if it's just correlated. So imagine that we had this data for an entire calendar year from January to December, and we wanted to try to explain drowning deaths. So this blue line, drowning deaths, is our dependent variable. And so we're looking through all of our different independent variables, things that might cause drowning deaths, and say we collected data on ice cream sales. And we were able to plot the number of drowning deaths each month, as well as the raw number of ice cream sales each month. And what do we notice here? My goodness, there seems to be a very strong relationship between these two variables. So I would ask you, well, what do you think? Does this mean that ice cream sales are causing drowning deaths? We see that as ice cream sales increase, drowning deaths also increase. So, is this a causal relationship? Ice cream sales causing drowning deaths? And when you're trying to answer this question, ask yourself, well, what are some spurious factors, some other explanatory variables that might explain drowning deaths? And what you would notice is that, drowning deaths, they increase in June, July, and August, and then they start decreasing September, October. What else is happening during those months? And the answer is that that's summertime. So ice cream sales increase during the summer. It's hotter outside. People are more likely to be outside and swimming. So what we have here is summertime acting as a spurious variable that's simultaneously explaining ice cream sales and drowning deaths. So it's not the case that ice cream sales cause drowning deaths. Instead, a better, more theoretically sound explanation would be that the increase and decrease in these variables is caused by the fact of it being summertime. So say we had a really bizarre research agenda where we wanted to investigate whether online dating had an impact on your likelihood of voting. So we can see we implemented this survey. We asked people if they use Tinder for online dating, and then we also asked them the likelihood that they voted in the last election. So out of all of the people who did vote in the last election, we see that 95% of them did not use Tinder. On the other hand, when we look at people who did not vote in the last election, we saw that 99% of them did use Tinder. And those are some crazy, obviously fabricated data points. But the point is, did using Tinder cause those people to vote the way that they did? Or is there a spurious intervening variable that might explain these voting behaviors? And a pretty good alternative explanation here might be that younger people are more likely to use Tinder, and younger people, generally speaking, are less likely to vote than older Americans. So there we have age as our spurious variable that is simultaneously explaining the likelihood of using a specific online dating service such as Tinder, and also the likelihood that those people were more or less likely to vote. So I hope that these two examples illustrate how spurious variables, just thinking logically through the relationship between the two variables, how those can explain away causality and say, no, these variables are related. I don't think that they're causal. In fact, another third variable, again, we refer to this one as Z, probably does a better job of explaining the causality of the relationship. Okay, and then the last part of this lecture, I just want to go through different methodological approaches. These are the most common methodological approaches that students generally use when they're getting started out in the research process. And I want to speak briefly to the extent to which we can make causal claims depending on the methodology that is utilized in a study. So you've heard me say a variety of times throughout this course that you need to have a large N. N in equations often refers to the sample size. So we need to have a generous sample size, not only so we can make appropriate statistical analyses, but also so our inferences that we make are generalizable. So yeah, while it might be really interesting to analyze just one specific case, how generalizable is that to the broader population? That's a major fundamental aspect of data analysis itself. So lots more to come on that. So let's just break down these 4 really popular methodological approaches and discuss the different implications they have for the extent to which that we can make these causal claims. And one thing that I want to point out here is that you'll notice that there's 2 axes here that vary from the amount of control that the researcher has over the cases that they are analyzing. And then the y-axis here varies from generalizable to narrow. And as researchers, in order to make causal claims, we need our study, our methodological approach to be highly generalizable, and we also need to have a moderate to a high amount of control over the subjects that we are analyzing or the observations that we are analyzing. And when we meet those conditions of having a generalizable study and having high control over those observations, that is the best case scenario of making a causal claim. And I'll explain why this is in a moment with these following examples. So causal claims are perhaps easiest made when we're dealing with randomized experiments. So when we're talking about experimental methods, these are methodological approaches in which the researcher has the most control over the subjects in the study, and that gives us more confidence in the ability to make a causal claim. I want to just briefly go through the characteristics of an experiment. I think in week 8 we're discussing experimental characteristics or experimental and survey studies that entire week, but the general characteristics of an experiment, which we'll go over today, is having a control group, a treatment group, randomizing your subjects into either your control or your treatment group, and then conducting a pre-test and post-test design. So what exactly do all these terms mean? Let's go through an example real quick. So let's say, returning to that original question from the beginning of the lecture, what impact does negative campaign advertising have on American politics, have on the likelihood that people vote? So we read the literature and we come to this theory that negative campaign ads, what do? They play on voters' fears. And that can decrease political efficacy, their trust in government, and overall reduce the interest people have in voting. So here with our theory, we're explaining why we expect exposure to negative campaign ads to decrease the likelihood of voting. So we would construct our hypotheses. People who watch negative campaign ads will be less likely to vote. And with what's unique about our experimental methodology is that we can control who gets exposure to a negative campaign advertisement. We refer to this as the stimulus, and who does not get exposure to the stimulus. That's the control group. So in the previous, example, I think we were just asking people, have you seen a negative advertisement? Did you not see a negative advertisement? And in the survey lecture, we'll talk a lot about, the pros and cons of just asking people flat out questions like that. But, they might not remember if they did see a negative advertisement or not, or they might be dishonest, or they might say that they saw one, but they weren't really paying attention. All kinds of potential for bias and reasons to not believe that those responses are reliable or valid, right? So what's unique about an experimental survey is that we can put people in a lab. We can make sure that, one group gets to watch the advertisement while another group does not. And then we can compare those differences with a survey that people take after exposure. And so when we tightly control for all of these different conditions, right, we end up in a position where if the respondents in our study who did watch the negative advertisement later reported very negative feelings about government and said that they weren't very likely to vote, and we compare that to our group of individuals who didn't watch the negative campaign advertisement, and we see that their attitudes remain relatively positive about government and that they still intend on voting, then we have a very solid case to argue that exposure to the ad caused the change in attitudes. Now, all of this brings us to the validity of experimentation. So anytime you're conducting experimental research, you have to, or even observational studies as well, you have to ask yourself whether or not your cases, whether your study has internal validity as well as external validity. So internal validity is research that demonstrates a true cause and effect relationship. You are in fact showing that changes in X resulted in or caused changes in Y. And there are a variety of things that we have to be weary of when we're conducting experimental or observational studies, making sure that we don't have any selection bias or priming or framing effects. We talked about that a little bit last week. Maturation and demand characteristics are also important. It's not super important that you understand these right now. We will discuss these in much more detail in the survey chapter. But internal validity just means that you are in fact accurately measuring the thing that you're trying to measure within that specific group. External validity, on the other hand, refers to the extent to which we can generalize the findings of our study to broader populations. And this is really important to understand early because it's going to help you kind of understand the essence and nature of statistical inference in its entirety later on in the semester. But with internal validity, just remember we're focused on the extent to which we are truly measuring the relationship among our observations, and external validity refers to the extent to which we can take our findings from our group of observations and expand that to the entire population, right? So if you're analyzing voting behavior in North Dakota and you're being very thorough about analyzing people who live in that specific state, that has a lot of internal validity. But to what extent can we generalize how people, in North Dakota feel? How can we generalize that to the entire country? Well, we might not have a whole lot of external validity there because the people who live in North Dakota might not be like everybody else in the rest of the country, okay? So lots more to come about internal and external validity, but I just wanted to, as always, introduce you to these concepts a little bit early. So let's just run through 3 quick examples of being able to identify internal and external validity issues. Number 1, Professor LaPlante stops people in downtown La Crosse from 11 p.m. to 2 p.m. and administers a public opinion survey on attitude formation. Are there any internal or external validity concerns there? Well, one might be, we might have some internal validity concerns if we're only surveying people downtown in La Crosse. We're probably going to be dealing disproportionately with business owners or people who work in offices. So is that representative of the entire La Crosse community? Probably not. And, we're interviewing them between 11 p.m. and 2 p.m. So that very clearly coincides with lunch breaks. So our sample would probably not be very representative of the population we were seeking to analyze, which is La Crosse. Do we have any external validity? Well, obviously, we're just interviewing one small group of people from one community in the United States. How representative are the people of La Crosse's viewpoints? How representative is that of the entire country? So we might have both internal and external validity concerns here. Let's consider prompt number 2. Professor Fairbanks asks UWL students the following question. Considering the importance of free speech in the United States Constitution, should groups like the KKK have the freedom to conduct public demonstrations? So obviously the biggest internal validity concern here is the priming effect that's going on here, asking individuals about, a notorious hate group like the KKK. Are they really going to be answering the question based on the, freedom of speech or freedom of assembly, or are they really going to be expressing attitudes about the KKK? Much more to come on topics of priming and framing in the future. And then again, with our external validity concerns, you're only surveying students from UWL. How representative is the UWL student body of, college students across the country? And then finally, a group of female researchers conduct interviews at the Old Wood Valley Recreation Center to gauge attitudes towards the gender pay gap in the United States. This is a very good example of demand characteristics. So, imagine you've got two women who are asking you questions about gender inequality, and you might not feel that there's a lot of gender inequality in the United States, but the fact that, two women are asking you questions about gender inequality, you might feel compelled to respond in a way that you think the interviewers will find socially desirable. So we refer to that as demand characteristics, that the characteristics of the surveyor might put certain demands on the respondent. Again, I'm not going to go into these in too much more detail. Those are just some examples of internal and external validity, and we will discuss these topics in a lot more detail in the following weeks. The next type of methodological approach that I want to discuss are observational studies. These are non-randomized studies, and this is the type of methodological approach that pretty much, I think, everyone in this class will be following. So data is collected from surveys or by simply observing the natural world. The researcher has less control over how the phenomenon is studied. It's not truly randomized, right? I mean, a lot of you are interested in lots of different examples of how X impacts Y, but you don't have control over deciding, which states have X and which states don't have X, right? So some of you are interested in, analyzing how marijuana laws, different types of marijuana laws might impact incarceration rates. And you don't get to control which states have marijuana laws that, that are more lenient and those that are more strict, but we just have to observe the natural world and make inferences that way. And that's what we mean by randomization and control. You as the researcher don't have the control over which group meets specific characteristics. And so typical variables in analyses and observational studies are things like socioeconomics, demographics, attitudes, public opinion, voting patterns, the behaviors or actions of international organizations, trading blocs, human rights groups, all things that we can observe in the natural world. So keeping with our American politics example of negative campaign advertisements, our research question, we'll stay with this example. Our research question investigates how negative campaign advertising affects voting behavior. Our theory is the same. Our Our hypothesis is the same, but instead of analyzing these relationships in a controlled experimental setting, right, we might not have access to those tools. So instead, we analyze available data on TV watching habits, and we compare that to the intention of voting. So all of this would be observational. Say we found a public opinion survey that asked these questions, and then we would examine the relationship in the observational data that was available to us. So, here's an example of what that would look like. We'd have our different participants. We would have data collected on their race, gender, party identification, and then our 2 variables of interest. TV habits being our primary independent variable of interest, and then the likelihood of voting, our dependent variable. And if we were to break down those last 2 variables into this chart, we could compare how TV watching habits corresponded to the likelihood that they would vote. And here we see a pretty strong relationship. This is evidence of, a strongly correlated variable. We see that among those respondents who don't watch TV at all to light TV watching habits, most of them reported that they were likely to vote, and none of them responded that they would not vote. But when we start increasing TV watching habits from regular TV to excessive TV watching habits, we see that the likelihood of not voting is increasing. So here we have some evidence to suggest that there is a relationship, that these variables are correlated. But do we have enough data and a strong enough theory to argue that these are causal? Is it the TV watching habits that is causing the attitudes towards voting? Okay, and then lastly, just to wrap up part 1, other types of studies that are pretty common but less common for the scope of this course, we have field studies and case studies. In a field study, the researcher collects data in the field, in person, rather than in the lab, in the office, or at home in front of the computer. So interviews, interviewing women soldiers in civil conflict in Somalia would be a really good example of an individual going to another country to interview specific people in the field. Perhaps you wanted to gauge public opinion from school children on their attitudes about health foods in school cafeterias, right? The act of you going to a specific location in the field, that's an example of a field study. And then lastly, we have case studies. This typically involves a detailed analysis of just one or a very few cases. So an example of a case study, you might be examining the difference between how Southern senators campaign at the national level and the constituent level. And the defining characteristic here is that we're dealing with a very small section of observations, but it's a very highly detailed analysis. Often it's one that's very qualitative in nature. Another example might be, how do human rights abuses differ between Algeria and Egypt? You're doing a very detailed analysis between a few, maybe 2 or just a few cases. Okay, and then just to summarize everything that we've discussed in this lecture, randomized experiments and observational studies are the most generalizable. They have the most external validity because we're dealing with a large amount of cases, and we're simply observing the natural world itself. We have a lot of cases to compare to one another, so the extent to which we can suggest that relationships that we find in our data are generalizable to the broader world, it's very clear to make those. It's very clear to make those claims in research. And on the other hand, we have field studies and case studies. These tend to be more narrow in scope and only examine a few cases in a very detailed way. So for field studies and case studies, we generally have a lot of internal validity. We're very certain that we are thoroughly analyzing the thing that we're trying to study, but external validity, we don't have so much of that. just analyzing the differences between Algeria and Egypt, what can that tell us about the relationship between all of the countries in Africa? Well, it's harder to make those generalizations because your analysis only involved 2 cases, okay? So I hope that this has clarified a little bit about the differences between generalizability and the narrow or broadness of a given methodological approach, and how that influences the extent to which we can confidently make causal claims in our research. So that's it for the part 1 lecture. I hope you enjoyed, and when you're ready, go ahead and go watch part 2.